Okay. Good evening, and let's start with today's lesson. Today's lesson, I want us to do the last part of trigonometry, which is the trigonometric dimensions, two dimensions and the 3 dimensions. Okay, so let's continue. That's how we can reference angle A in triangle ABC. And then going further, we can reference angle B. So I'll just write on the space up here. Now, angle B in triangle ABC, we can start referencing it angle B. So we know that angle B automatically is 90 degrees because it's labeled or it is given. And then we can still reference it with 3 letters. Letter A, B, C inclusive on it, but make sure that letter B is in the middle. We can write it in the form of A, B, C. Now, as long as letter on which the angle is in the middle, then that letter will give it a cap up there. Then we know, or you are now telling the examiner that the angle is at B. Or you can still do the same thing, start with C and then followed by B and then followed by A. And then you still kept B up there. When you kept B up there, it means the angle is up there. But when you kept C here and then you don't keep A in the middle, for example, it means what you are doing is wrong and that is not correct. And there is no angle we are talking about here because that is not how we reference the angle. There is a right way in which we can reference the angle. Or sometimes these angles, they can be represented by the special symbols. For example, let's assume that A is theta. We know theta itself, it's mostly a featured angle in most of the case. And then we can have letter angle at C represented by beta. Beta, we know it how it's written. Then we have angle 90. Angle 90 is fine, no need to reference it. It's the same as it is. So if either they don't give you theta and beta or any referencing in a triangle, this is how you will reference the angles inside the triangle. Please do that and then make sure that you will get it correct. So now we know that angle at B is 90 degrees. If we are to give a reason on it, is given, or someone can say it's a right angled triangle. So if it's a right angle triangle, the two lines are perpendicular, making a 90 degree where they are intersecting. So this is how we reference the triangle. Now, as we start now, I want us to start with the area. At first, I said that we were talking about the 3 triangles. This is the first triangle. Let me input the second triangle. The second triangle, we are just, I will just remove the 90 here. When I remove the 90, it means the triangle is no longer at the right angle, which means there are no two lines that are perpendicular to one another. So I will just assume that this one is alpha, angle alpha, or right angle alpha in this way. Now, no sides are equal this side, so nothing. All the angles are different and no sides are equal, and then no angle is 90. So this type of triangle, in most cases, they call it an obtuse triangle. An obtuse triangle meaning one of the angle is more than 90, like angle at alpha, it's more than 90. And then we also have it an acute triangle. Acute triangle meaning all the angles in a triangle, they are they are less than 90. So those type of triangles, we call them the scaling triangles. No sides are equal, no angles are equal. So yes, it's a scaling triangle. So going further with this one, we still reference it the same way in which we reference the angles. If the angle is at A, which is theta, we'll still reference it the same way. If angle is at B, and then we will still reference it the same way. So what is important here is to reference whatever the triangle you are given, reference the angles with the correct way. Then the last type of a triangle, we are having a triangle which is an isosceles triangle. On an isosceles triangle, we are having two sides that are opposite and they are equal. Two sides that are opposite and they are equal. So in most cases, they will either give you that two sides are opposite and or they are equal, or the examiner may not show the on the statement, but sorry, may not say on the statement, but may show on the triangle by just simply putting one line on each of the two triangles lines or sides. So by saying that, it means that the two sides are equal and the two sides are opposite. Therefore, if the two opposite sides are equal, it means also the two opposite angles are equal. Therefore, which means we can now apply the isosceles triangle properties, which means now we will say that either angle at B is equal to angle at C. Either angle at or also say that side at A is equals to side at B, which is the same thing. So we can work around depending on what are we looking for, and not forgetting that the sum of all angles in a triangle, they add up to 180. So this is how we reference the angles in a triangle. Now, the first part I want us to talk about the area rule. The area rule. Now, on the area rule, let's get to the business. On the area rule, we are talking about the area of a triangle. The area of a triangle is simply stated by the formula saying that area of a triangle, area of triangle. This shape, it represents triangle. So it's small triangle written there, but it's equals to half of the base multiplied by half of the base, and then also the side if it's possible, or the height if it's there, and then multiply by sine angle. Let me just assume the angle is theta. I won't try to prove these things because proving it might be somehow not possible for you to understand, and also not available in examination. So I will just put how we derive the equations from one another to the other. So now here, area of a triangle is simply by this side A, which is B, and then B representing the base, side 2, which is a height, and also angle in which that there is no side on. So we have to reference the sides according to. Now, remember, there are 3 ways of a triangle. There was a first way of a right angle, the second way of a scalene, the third way of an isosceles. So the theorem, or sorry, the area rule, it applies to all the 3 triangles. This is applied to all the 3 triangles. Let me draw triangle number 1 here. Triangle is right angled with A, B, C, and then triangle number 2 as an isosceles with D, E, F, and then triangle number 3 here, which is G, H, I. So here we are given the sides only, no angles. So we can find the area of all the 3 triangles if we are to assume. Let's assume angle theta is here. This is angle theta. Kamo angle theta, let's assume is here. Kamo angle theta, let's assume angle theta is here. So the theta is the same in all the 3 triangles. Then the area of a triangle in an isosceles, we are going to talk about area. So you must make sure that you either have the 2 sides. So let's start with the right angle triangle. Right angle triangle, we must have the 2 sides, please. You must have the 2 sides. And the important thing on a right angle triangle, it is to know that the area of a triangle is equal to base multiplied by height. And then base here is going to be the x value on that triangle. So you will know how to label the x value. Remember what I said, we label the x value by saying that on the 90 angle, we just draw a line pointing the longest side, which is the hypotenuse, or R, and then the side in which the angle is, it represents the x. So which means now the base is going to be side BC, and then multiply by the height. Height is going to be the y side, which is AB, multiplied by AB. And then the other part that is missing, it's side R. Side R doesn't have a known side. So we are going to take what? We are going to take angle in which is opposite to the side, and angle is 90. Then we're going to say is sine 90. So if it's a 90 like this one, sine 90 on a calculator, it's 1. So that is why the formula of area of a right angle triangle is just only base times height, because the angle sine 90, it's only 1. So everything is just like multiply by 1. That is why we'll just write half base times height. That is the area of a right angled triangle. Make sure that you always have this side and also this side. But while hypotenuse is not just important at the moment, but then if you will have, if it happens that you have this side AC, and you also have this side BC, it's important to use the full formula of with the side. How so? Because you don't have the side AB, and side AB is opposite to this angle, which is angle theta. So which means our new area in that case, even if it's a right angle triangle, it's gonna be what? It's gonna be the side that is available, which is side BC, multiplied by the other side that is available, which is side AC, multiplied by the angle of the side that is not available. The side that is not available is AB, which means it doesn't have the reading. And if you can't find it with the theorem of Pythagoras, then you can just simply do like this. If you have the value of theta here, and then you will put sine value of theta, it will give you the same answer as if you will find the value of this AB on the Pythagorean theorem, and then after you substitute on this formula, the answer will still be the same at the end of the time. Now let's go to the second triangle, which is an isosceles triangle that has the same two sides, which means or the angles inside also, the two opposite angles inside are equal. Now when the two opposite angles inside are equal, then now we know, as they said, it's an isosceles. Now which means angle this one and angle this one are the same. So let's just say this is angle X, therefore this will also be angle X. But then this one is what? This one is theta. So theta plus x is 180 at the end of the time. But we are not there. Let's find the area of this triangle. Area of triangle simply says half of the base multiplied by height multiplied by sine angle. Now, angle A, it can be anything. This theta doesn't mean specifically to this one. Now, listen again. The triangle, there will always be the two sides provided, or all the three sides provided, and or an angle given. But if there is no third side given, you are only given the two sides on a triangle. That is the minimum requirements for area. You only need two sides that are known, and then the third side that is not known, make sure that the angle is available also. Let's start to see. If now we are given side DE, so remember our side DE is, we are only given side DE, and then we are also given angle theta. We are also given, which means angle, let's assume angle theta is 10 degree. If angle theta is 10 degree, and then side DE is 5 centimeter, I'm just assuming, right? Then we're not forgetting that this triangle is an isosceles. If it's an isosceles like this one, it's obvious that then we are going to say, okay, let me not use 10. Let me use 70 for Christ's sake. So then we are going to know that angle X and X are the same, but then side DE, which is the given one of 5 here, is the same side with DF. The two sides are equal. So with here is 5, here is 5. Now the third side, which is side EF, it doesn't have the value and it is not given. But the opposite side and also the opposite angle, the two opposite things, angle and a side, we are only having the given one of the two, which is the angle. So which means we can use theta or angle 70 on our property of this formula. So now we are going to use side number 1. Side number 1, which is side DE, multiply by side number 2, which is DF, and then multiply by sine of the side that we didn't use. We didn't use what? So side angle, or the angle of the side we didn't use. We didn't use side EF here. If you can check, there is no EF. EF is not available. But the opposite angle to EF is theta, and the theta is given, that is 70. Then it is the sine angle 70 that we use. We will use 70 here as the opposite part on an angle. Then you will still get the same value. Remember, when DE is 5, you will put 5 here. DF is 5, you will put 5 here. Then you will get your values, and then you will be having the area of a triangle. That is how it works, and then that is how it works. So make sure that the triangle is either complete with the two sides, and the other side that is missing, it is having an angle. Or you can have all the angles of a triangle there, and also at least 2 sides on it. then as long as the triangle is not the right angle triangle, then you can now figure out the area. That is how you work out on the area. Now, the same procedure here, it works on an scalene or an obtuse triangle, this one. When we say that the two sides that are available, if it's given by any chance that we are having side GE, if you are having side, sorry, GI, and then we are also having side HI, we're having side HI, but we don't have what? We don't have side GH, no side GH, but angle at I. Angle at I is given that it is theta, and the theta, it has the value. Now we can now still find the area of a triangle the same, because we are now having the two opposite sides, which is side GE and side, sorry, GI and side GH. The two sides are opposite. And then the third side, it doesn't have what? So we have GH and also HI. Yes, sorry about that one. We have GI and HI. The two sides are opposite to one another. But the third side, that doesn't have the value. It has what? The opposite angle on it. So we can use that opposite angle on the sine formula so that we can get what? We can get our area. So every time when they want the area of a triangle, make sure that you have either two, sorry, you make sure that you have two, what again? Two sides known, and at least one angle that is opposite to the side that is not known. That is always the case of the target. Please don't forget that. Are we clear on that one?
Yeah. Yeah.
So which means we pass on the area, right? Okay, let's go to the second part on it. So area can be expressed in many ways. Just print this, just put this triangle here on the screen. So we can see this triangle. This triangle is not a right angled triangle. So as it is not a right angled triangle, the area according to the angle. So if you can check, we have an area if the angle is at angle A. So if it's at angle A, it means for the side in which that the angle is opposite to, we don't use. So if you can check, angle A is here. And the side that is opposite to this angle A is side A. It's side A. So side A is opposite to angle A. Therefore, on our sides, the two B multiplied by H. Now we are going to take B as this B on the referencing of the triangle and C as this C. You can see there is no way they have used the side A. They haven't used it anywhere. But what did they use opposite to A? They used angle A. The same thing, it means when we are now given side B and side C as on the statement or also on the diagram. But what will happen if now you are given side A and side C, and then you don't have side B? You can now then use to say that side B is opposite to this angle at B. So which means when any of the letter is available, you can see we have A, we also have B, we have C, but A and C, they are the side, but B is what? B is an angle. So when we go to the third part of it, so which means you can just apply it according to what you have. You can just apply the formula according to what you have. It's not always the case that you come back to verify. Just know that the formula is half of base times height multiplied by sine angle. Which angle? Angle and what is height? Height you are talking about, in most cases, height is used when it's a right angle triangle. But then if you just read in that way, barata or half base multiply, sorry, half of A, side A multiplied by side B, and then multiply by sine angle C, which is this one. So you can write this formula as long as it's not the right angle triangle. The formula of the area is like this. And what I like about this one is also there inside your formula sheet of mathematics. So you will just choose it. As long as it's not the right angle triangle, you will choose it and you will know how to use it. Shall we move on?
Yeah.
Okay, the second part. The second part here, the same triangle. Now we are introducing how do we then find those missing sides and those missing angle. If then we come back to this part, we are only having maybe two sides given. We are having BC given. We don't have side A. Then how can we find that side so that we can what again? So that we can what am I saying? So that we can find all the three sides on a triangle. Yes. And then also find all the angles in a triangle. Now, there are simple formulas that we have to use or that we can use. Now, let's come back here and see which formulas can we use. Now, we are having the first formulas here. The first formula is of sine rule. Sine rule meaning, Warren, we are applying sine. We are applying sine. The same sign we were doing in a trig ratio is the same sign you see here. So how does this thing work? Now, in most cases, I like this one. The second one, which is this one. Me, I like this one. So I will talk more about this one because initially when I was taught, it was this one. But then the same thing, it works with this one. So you just start here when you see the angles come on top, the side come at the bottom. Here the side come at the bottom, the angle comes, or sorry, the side comes on top and the angle comes at the bottom. So the answers at the end, they are the same. The answers at the end, they are the same because the ratio that you will get here and also here, it shall be the same values. So they will end up giving you the same at the end. When you calculate, it gives you the same correct values. So it depends if they taught you initially at your school any of the two, then it's up to you which one you go with, but they all works. But then let's see. Now this we works when we are having two sides. We are having two sides. When we are having two sides, when we are having two sides, they are conditions. The first condition is two sides. The first condition is two sides given. What do I mean two sides given? It means now our triangle, it has two labeled sides that are known. Let's say, for example, it's side A and side B that are known. We don't have side C. We don't have side C. So when we don't have side C, yes, we can find side C or somehow, but then examiner will not what is it? Will not leave you nor forsake you when coming to information. So those two sides that are given, the two sides with what? Two sides given with one angle. So the examiner will give you two sides with one angle. Two sides with one angle can be which one? Let me just predict now so that we can now understand. If we are given angle at C, and then we are given side A and also side B. So which means what we don't have, I will use a red marker here. What we don't have side C. We don't have angle A. We also don't have angle B. So what can we do? We can now then say that, oh, the condition Yamatomage, two sides given with one angle. But then knows, look, identify which angle is it and which each and every angle, it has to be opposite to the side so that we can understand. Now, if I'm talking about angle A is not known, but angle A is opposite to this side, which is side mang, side A. So which means on the formula, I'm going to use sine rule. On the sine rule, I will say angle, so the side A divided by angle A. Or I can say angle A divided by side A. So I can choose any of the two. And what is known here? Only what is known is side A. So I will input the value and then it's equal to what else is known is side B. Then I will say what? I will say side B divided by angle B. Angle B is the one that is opposite to this side, which is this one. And then divide by angle B. And do I know the value of angle B? No, I don't know the value of the angle B. Then I'll just say sine angle B. And then I will still say it's equal to, then side C. Side C is not known. It's not known. Side C is not known. And then it's equal to what? It's equal to angle at C. And angle at C, we know it. Then we will put angle at C. Then after then, we can see how these things works out. But then let's go back to our condition of what? The condition of two sides with one angle. So how can we work with this condition, or how can you identify this condition that it can work for you? Meaning, or two sides with one angle that is given. The two sides that you are given, you must make sure that, or they will also always make sure that one of these sides is opposite to this angle. They will make sure that one of this side, let me write it in this way. One of this side should be opposite to the angle, or to the given angle. Now, if then we are given, let's make our condition be correct now, so that we can know when and how do we work it out. If we are given side A and also side C, for example, now I'm coming back with an example, side A and side C, and then the angle, the two sides meet requirements, then with an angle. The angle, it can be either at C, and at C is this one. Or it can be either at A and at A this one. So let's say the angle is at C. The angle is at C. And the angle at C is a value given. Let's assume that here is 5. Let's assume that C is equals to 5. 5 units. And then A, let's assume A is equals to 10. Sure everyone is with me. A is equals to 10. And then the angle given at C, let's say maybe let's say maybe it's 56. Just an example, 56 degrees. Now we can use our sine rule in peace. We can find, first thing that we can find is the angle. Not the, I have a question barring with 4 marks, find side B. But find the value of side B. We don't guess, we have to work it out. Now the condition of two sides given with one angle. One angle should be, that angle should be opposite to one of the given, one of the sides should be opposite to the given angle. So here we have given the statement to be correct. The angle 56 is opposite to one of the sides, which is 5. So we use sine rule. Remember, we go with this one at first. So we will have what? We will have simply 5 divided by 56. And 56 here like angle. It has to be an angle. So angle goes with what? It goes with sine. So don't forget, it goes with sine. So it's 5 divided by sine 56. And then it has to be equal to, it has to be equal to 10. Remember, we work with what we are given. 10 divided by sine. Sine at which angle? At the angle in which that the angle is opposite to this side. Which side? Side 10 or side A? The angle is angle, capital letter A. So we'll put angle A here with a knob on top to show that it's an angle. So what do we do there? We will do our cross multiplication. Our cross multiplication will work out for us. Remember, the most thing here is just the mathematical basics. Apply your knowledge, then mathematical basics. Simple. Then on the mathematical basics, we'll say that we are having 5 divided by sine 56 is equals to 10 divided by sine angle at A. Mathematical basics. So what do we do here to solve for angle A? We will do what? We will do cross multiply. Cross multiply. So we will have 5 multiplied by sine angle A is equals to 10 multiplied by sine 56. So someone with a calculator there, help us because mine is offline. So we need sine here to remain as a value itself, even though this one it can give us error, but we have tried. We have made our piece with an example and how it is worked. I know it might give us error. I'm sure about that one. But then this is just an example. Side by 5, then we will have sine angle A is equals to 2 sine 56. Remembering it's mathematics, we just apply. You can skip the steps sometimes. Then remember, if we are having sine and angle, and then we are looking for an angle, what do? We should start saying that shift sine equal to -1, get arc sine, and then puncture everything 2 sine 56, close the bracket, it will give you the value. Now, if my numbers, they were an accurate one, it should give us the numbers, but if they are not accurate one, it will give you math error. So if it gives you math error, don't say I'm giving you a false or unknown examples. I'm just estimating for you to understand the calculations. We will get to the real deals, but knows how we work these things out. So 2 of sine 56. And unfortunately, it's a math error. Yes, I knew it would be math error, but it's fine. So if the number it was accurate, which means we are going to have the value of angle A. So on our triangle, we are going to fit our triangle. Here we have 56. Here we are having 10. Here we are having 5. Here we are having small letter B. And then we are looking, so here we will have our value. So if our value is known, we can now find the third side. Remember the question was saying find angle at B. So now we can find, sorry, side B, not angle at B, side B. So now we can have angle, the last angle here, the angle here, by saying what? Angle 56 plus the angle we found plus this one, they give us 180. Now let me give you a live example. Let me give you the live example. Now on a live example, we will never go wrong. So from there, before we can go to the live example, from there we will have this angle reading, and then we will say letter B divided by sine on this angle, and then the angle or the sine on this angle, the angle sine on the angle is going to be angle at B. So we will have the value reading here is equals to any of the two or any of the two that we know, which is small a divided by sine angle that we found, which is at A. Or someone can just say not this one and can write C divided by sine angle at C. And angle at C is 56. So you can use any of the three. So remember, when we equate, this one is equals to this, or this one, it can be equals to this. You can choose. But on the formula, they have given you the 3 options. All the 3. Okay, let me just give an example of question 5. The real one with the same application. Now we will assume that the triangle is not the right angle. We won't treat it as a right angle. Am I clear? We won't treat the triangle as a right angle. Yes, it's a right angle, but we won't treat it as a right angle. Because when we treat it as a right angle, it's a different structure or different workings. We will work it with the single trig ratios as we were working on the previous topic. Just saying cos is equals to x over r, y is sine is equals to y over r, tan is equals to, we will treat it in that way. So now we are having a triangle given there. Let me copy it down with 4 root 3, and also we are given 8. Okay. Oh, let me use, which one should I use? Wow. Quick, okay. What you say? Okay, let me use this triangle because this one is going to confuse you for the rest of your life. Yo. Let me use triangle APD. APD. Ma? Hello?
Look, man. Do you mind to repeat the same question that we were doing now before we go to the other one?
I'm trying to give a real example because that one it gave us error because the numbers were not accurate. So I'm trying to bring a live one that is existing here.
Okay.
Okay, now we can see the diagram. I only took triangle APD. And don't ask me where I got 60 from. I skipped the steps. Okay, let's see. Our triangle is triangle APD. So with the reference to angles, let me remove the axis and the other one. With the reference to angles, we are having angle at A, we are having angle at D, we are having angle at P. That's why I'm putting these caps. It's only when it's one triangle we can use that. Then if you go to original diagram, it is having two triangles. So that is then we can now start to label triangle A as triangle D, A, P. That's the one you can label triangle D as triangle A, D, P. A triangle P as triangle A, P, D. It's only when, we use this mostly when we are having more than one triangle in one system or in one diagram. So again, remember there was Y here, I have removed it. So again, if we are given such like this one, angle A, which is this one, is more the same as Y. So when you use this one, it's more like you are writing this one, and it's more like you are writing this one when there is no other triangle. So you can use any of the three if it's like this one, you are approved. So angle at D, it doesn't have any value. We just leave it like that. Angle at P, it's 60 degree. That's how we reference the triangle. I'm starting from the beginning of the introduction. That's how then we reference the angle on this triangle, three of them. Not forgetting that the sum of all the angles in the triangle, they are 180. So if we were to add these three triangles, these three angles in a triangle, they must give us 180. That's the angles. Let's reference the sides. We have side AP. We also have, okay, let me write it here. We have side AP with capital letters. We have side AD. We also have side PD. That's how we reference the sides. In substitution, when they have the values, side AP becomes value 8, or 8 as a number for measurements. And then side AD doesn't have a value. We leave it as side AD. While side PD, it has the reading, which is 4 units. Here we are. Then after we have labeled our triangles, sides, and angles, we are looking for the triangles, angles, and the sides that are opposite to one another. We pair them. The aim is to find sine rule. We pair. Let's start pairing. Angle 30, angle 60 is opposite to this side. I'll just throw a line like this. The arrow in which that there it is pointing the side that is opposite to this 60. So the side opposite to 60 is what? It's AD. So now we can see it's AD. So simply in our, let me wrap because I assume you are writing. If not, then Tolo, you will wait for video next year. Which means side AD now is opposite to angle 60. So which means it's opposite to sine angle at which is 60 is angle APD. You see now, I'm doing something here that you you will have to do on your own when you are alone looking for what you are looking for. Get the first option. Then it has to be equals to something else. Let's take side A8 or draw angle, sorry, from angle at D, we draw an arrow pointing which side? Side 8. So which means side 8, which is AP, is opposite to angle at D, which is ADP. Then the remaining is angle at A, which is Y. Draw an arrow again facing the side. It's facing side 4, which is, I'm gonna space more, so I will write here, which is the same equals to side 4, which is PD or DP, divided by, or it is opposite to angle Y, which is angle DAP. Now, this is my sine rule formula for this small triangle. Please. If you have a space, you write all the three like following each other. 1, 2, 3. If you have a space going further, 1, 2, 3. The equal sign comes this side. Now, the question will ask you, they will ask you. And when they ask you, how will you answer? Let's see how will we answer. The question will say find side AD. Side AD. And hey, side AD is difficult to find. But no, it's not. Let me wrap this part for sake of space. Also, I'm okay, the aim is to find AD. But AD is opposite to sine 60. So which means we have AD opposite to angle sine 60. It can work for us. Maybe we can use it later. If we are to use it like this, we only have one angle. Remember the rule. If you are given two sides and one angle node, that one angle, it has to be opposite to one or on AD. So here on our case, hey, we are finished. We don't have any of these sides here that is opposite to this angle, which is 60. So on our examination here at home as well. So which means now it leads our triangle as an incomplete. It doesn't have complete values that we are looking for. So which means we can now start to go and prioritize on the bigger triangle and see what are we missing from there so that we can come back and figure out the values. Are we clear on that one? Hello, people, are you still there?
Yes, I'm still here. Can you please repeat what you've just said? I mean, the last statement that you were saying now.
The last part was saying, the question is saying, let's find side AD. We must find side AD. And if we are to find side AD, we are given this one as 60. And let's see if it meets the requirements of saying that we are given the two sides here. Now, when we are given the two sides, and then we want to use sine rule, it means what the two sides we are given, one of the sides, it has to be opposite to angle given. So unfortunately, on our side here, or on our properties, this triangle, it doesn't meet the requirement of being worked with the sine rule. But then the formula of sine rule is still the same as we have predicted before. So which means we can use the other rule in which that now the rule, it has to work for us. So which means now the properties of sine rule here, they are not met. Meaning the two sides given, with one angle. The angle has to be opposite to one side. So unfortunately, this angle is not opposite to 4 or 8, but it's opposite to the side we are missing. And we don't have the angle at D, any other two angles. We don't have them. They are unknown. So we cannot use what? We cannot use sine rule. That is where we are going to a new rule in which is cosine. This is where the original triangle comes from. Remember, the triangle was triangle ABP connected with triangle ADP. So I only took triangle ADP for the sake of progress to just explain how the sine rule will work on this triangle if we are to find anything else. See lab. Okay. We come to this. I said that the sine rule of this, we are also given this side as y. The sine rule of this triangle, we start by labeling the sides. The first side that we will label here, it's side AP. Side AP. We also have side AD. We also have side PD. Three side. Side AP, it's 8 units. Side AD, it's unknown, we leave it. Side PD is 4. And then after we label the sides, we label the angles. Angle at A is angle at P, angle at D. I said that we only use the one single letters of angles if the triangle is 1. But if there are more than one triangles connected, then we have to use the three letters. Like for example, angle at A, it will be either D, A, P, or P, A, D. But then the curve of an angle is in the middle of A. At P, it will be A, P, D. I start alphabetically so that you can understand. But the curve will be on the P because it's the middle one that has an angle. Angle at D will be A, curve D, and P. And then now they are having the values that are given. Angle at APD is given as 60 degree. Angle at DAP is given as small letter y. While angle at ADP, it's not referenced. We just reference it in our own way in this manner. Now, if we are to look for sine rule of this triangle, I'll have to wrap now. If we are to look for the sine rule of this triangle, we will say that by saying angles, let's position the angles and also give the reference to their side. This side, I'll draw a big line pointing an arrow. The side in which this angle is pointing, or this arrow is pointing, is the one opposite to the triangle, sorry, to the side, and also opposite to the angle. Then we will say side AD, let me write it here, side AD is opposite to angle 60. So it's AD divided by sine 60. Sine rule, I'm creating sine rule formula for this one. Then it's equals to. Then again, what am I having? I'm having AP, side AP, divided by. Now the angle at this side, or I can say side AP. I can draw the arrow from any of the side. If I'm drawing from the side, I'm looking for the angle. If I'm drawing from the angle, I'm looking for the side. So this side is going to give me AP. AP means opposite to angle at D. Then I'll say sine angle at D is ADP. Then again, or the third one, side DP. Side DP, if I draw the arrow this way, it's gonna lead me to angle at Y. Angle at Y, which is angle DAP. So simply this one, it can be written in a form of AD divided by sine 60 is equals to AP, which is 4, divided by sine of angle D, which is equals to dp, which is wait, AP is 8, sorry. And then a dp, which is 4, divided by sine angle is y. So this is the sine rule of these two triangles, of this one triangle at the end. So here they can ask you to find the question. The original question was saying, let's find side AD. But according to the properties that I told you, that a triangle, if you are given the two sides that you are given, they must also gives you one angle. Yes, you are given one angle, two sides and one angle. But unfortunately, the angle that we are given, it is not opposite to any of the two sides. So we cannot use sine rule. But this is the sine rule of this triangle. So which means every triangle, it has sine rule. So you can just take out its sine rule the way you understand how I took this thing out here. But we're not to solve AD now with this rule. Doesn't work for us. That's what should happen into your mind. When you try to put sine rule on this triangle and it doesn't work for you, it doesn't mean you don't know how to work it. It means use the other options are there. There are in English, there are many ways to kill a cat. So use the other means. So let me wrap here and introduce the last part, which is cosine rule. Maybe cosine rule will help us. It will help us to find AD. But let's see. The same properties apply, meaning D is opposite to angle. So angle D is opposite to side A. Angle 60 is opposite to side AD. Angle Y is opposite to side 4. This, it applies everywhere. Now let's do the cosine rule here on this triangle. The same properties still work. Side Y, angle Y is opposite to side 4. Angle 60 is opposite to side AD. Angle D is opposite to side 8. Same thing works. I'll simply go to the formula straight. I won't ask, or I won't show how we derive the formula, because they won't ask you to prove the formula. Now, here on this one, the aim is to find two sides given. Okay, two sides given, one angle given. Now, if you can see that the statements are the same as the other one of a sine rule, but this one, it changes. The angle is not opposite to any given sides. Can you read my writings? Two sides given with one angle, okay? But then the angle that is given is not opposite to any sides. Okay, good. Which means this triangle is a perfect example for this, because we are given two sides, 4 and 8. And we are given one angle, which is 60. An angle is not opposite to 4 and also to 8, but it's opposite to 80. Then what can we do with this thing? The question, we will find the third side. The question will be find the third side. The question will be find the third side. Or the properties can still work again if we are given three sides. Three sides are given, which means side 4, side 8, and this side it's known, a big 6. Just assuming. Then no angle. No angle is given. We are only given three sides. We can find what? The question we can say what? We can find any can find any angle. We can find any angle. These are the properties that will work on a cosine rule. Square level. I give you a minute. Please write them down. The first part on it says two sides with one angle is given. Continuing further, the angle is not opposite to any sides given, to any given side. This statement is wrong. Then the question that will come likely will say, find the third side. Now this will apply in the formula that we will do here. The next thing, the second property they can give you. You are given the three sides of a triangle with no angle inside, no angle given or no. What can they ask you to find? You can find any angle inside a triangle, any of the three inside a triangle. That's what they can ask you about cosine rule. Shall I drop and continue?
Yes.
Okay, let's create this formula from this triangle that we're talking about. The original formula says that side A to the power of 2 is equals to side B to the power of 2 plus side C to the power of 2 minus 2 multiplied by B, side C, and also multiplied by cos angle at A. Here the formula, you will find it in your formula sheet. Okay, keep BC squared. Something squared. Let me check. I might miss it somewhere. Let me verify the formula. Okay, it's correct. Formula is correct. Right, what number is the formula? We can see the formula, right? Okay. Now, let us relate this formula with this triangle. Let's start with the three sides first, because now all the three sides are available here. It's up to you which side is A, which side is B, which side is C. But when it's up to you which side is A, which side is B, and which side is C, make sure that the side that you will put here as the subject of the formula, it is the side that is opposite to the angle you will put here. The side here is the one opposite to angle. The side you will put as subject of the formula here, the side squared, it is the one that is the side to the angle you will put here. Let's go to our triangle ADP. If now I'm looking for side AD, it means on my formula, before I go to my formula, in my triangle, side AD is opposite to angle 60. Let me create the formula before I can substitute. I will have side AD to the power of 2 is equal to. So which means at the end, I will have cos 60. Why cos 60? Because the angle is opposite to the side that I am looking for, or that is unknown. So what does this tells me and you? Be careful that when you choose the side you put here, you put here, you put here, make sure that there's an angle known. Or if you are looking for that angle, make sure that this side you put here, it is the side opposite to that angle. If you can't understand this English, then you won't do this thing. And practically in every exam, one question will come that looks for you to solve it with sine rule, with cosine rule. Now, I'm repeating for the last time. The side that you choose to put here on this formula, it has to be opposite to the angle. Let's start with the first part. The first property said we are looking for the third side. Now, if you're looking for the third side, we are having one angle given, and the angle here on the triangle is opposite to the side, which is side AD. That is why I started with AD here. So which means at the end, whatever I put inside here, it will be, I will choose which one is B, which one is C, and then I substitute. But then here on cos A, it has to be the angle opposite to this side, which is 60. That is why I put it far back here. Then let's choose which one is B. B is AP. Then I will say AP to the power of 2 plus. Then C is PD. PD to the power of 2 minus 2 of AP multiplied by PD. Then multiply by cos 60. This is the formula. Then we go to substitution. When we substitute, we will have AD to the power of 2 is equals to AP is 8. I will say 8 square plus PD is 4. I will say 4 square minus 2 into bracket 8 multiplied by 4 cos 60 is 1 over 2. Then I will punch everything in a calculator and then remove this square by squaring both sides. And I will have AD is equals to a numerical value. That is when we are having two sides, one angle, and the angle not opposite to any of the two sides. We are looking for the third side. That's how we will find the third side. So here it gives me, when I punch on my calculator, my calculator, not your calculator, my calculator, it gives me 4 root 3, which is 6,9, almost 7, approximately 7. So now it means I can find my triangle is fit like this. I want to wrap for space. Let me wrap. Allow me to wrap, because when I write, you write. I leave only the triangle. Now the triangle is fed with 3 sides. If you can see, the triangle now is having 3 sides. Now when the triangle is having 3 sides, and we are only having one angle, we can find all the angles. We can find all the angles. The first angle that we can find is the angle Y and or angle at D. So let's start with angle at Y. So we're having 3 sides. We want one angle. Good.
Yeah.
So the formula said that a to the power of 2 is equals to b squared plus c squared minus 2bc multiplied by cos A. I repeat again for the last time on the second part. We are having 3 angles. So we are having 3 sides, sorry. And then we are looking for any angle inside. And the angle we are looking for is angle at A, which is Y. So the number, or sorry, the side in which that I will put as a subject of the formula here, it has to be the side opposite to this Y. Be careful there. Then that side is side 4, and 4 is DP. Then I will have DP to the power of 2 is equals to, then any of the two sides I choose in between, that AP, it's B, plus AD, it's C, minus 2 AP, AD, cos of angle, which is Y. See now. So we're looking for angle at Y. we must use the opposite side to angle y. Substitute. We will have 4 squared is equals to AP is 8 square plus AD 4√3, or in all the bracket square minus 2. AP is 8 AD 4√3 cos y. Let's look at our smart calculators. If we have calculators that you just do mathematically. So we will have 8 squared plus, what is it? Plus into brackets 4√3. 3. Kambola when I calculate. TP. Okay. Okay, which this one will give us 112 minus, okay, 2 times 8, it's 68. 2 times 8 times 4√3 is equals to 64√3 cos of y, and then this side is equals to 16. Then I will take this one to the other side, which means I will have 16 minus mathematical workings here. I'm working mathematically. 16 minus 112 is equals to minus root of 64√3 cos y. Mathematically, must also be taking it down because my screen is full. So I'll have 16 minus 112. They give us minus 96, which is equals to minus 64√3 cos y. Then how do I get rid of this one? I wrap my again, only my, what is that, triangle, and then I will rewrite negative 96 is equals to negative 64√3 cos y. Then I divide both sides by negative 64√3. Negative 64√3. And then negative 64. 96 divided by 64√3. So this give me √3 over 2, which is equals to cos of y. So I will say on a calculator, shift cos yampaso, then √3 divided by 2 is equals to y. So this will gives me 80 is equals to y, if I'm not wrong. If I am not wrong, I want to shift cos √3 over 2, yeah, state. Then y is 30 degrees. So which means we can find the other side of that third angle of that triangle, which if it's here we are having 60, here we'll be having 30, and the remaining part to give us 180 is 90. And we just figure it out. So the third side of a triangle is always easy. Yeah, here we are. Any question?
Yeah, no question from my side.
So which means the important thing is to see the triangle and see what you are given. So when you try to analyze a triangle, you will see the properties I was telling you. So it will tell you either is cosine rule or a sine rule. Then you can find the side. If it's cosine rule, it has to give you 2 sides with 1 angle and then a no side opposite. They won't tell you these things, but when you analyze, you will see. Then you're done. If there's no question, I would like to give you questions.